Lesson number 2, Algebra, Volume 4. Application number 4. To assemble table induce operation of addition and multiplication in class residue R5 equals 0, 1, 2, 3, 4, included Z modulo 5. 5 divided 5 equals 0 rest. 5 equal rest 0. 6 divided 5 rest 1. 6 equal 1. 7 divided 5 rest 2. 7 equal 2. 8 divided 5 rest 3. 8 equal 3 in class residue modulo 5. 9 divided 5 rest 4. 9 equal 4. 10 divided 5 rest 1. Rest 0. Ten equals 0. Repeat. R class residue R5 equals 0, 1, 2, 3, 4, included Z modulo 5 equals 0, 1, 2, 4. Table for plus, table for multiplication. 4 at 4 equal 16 equal 1. 15 divided 5 equals 0. 3 multiplied 3 equal 9. 5 equals 0 in modulo 5. 2 multiply 4 equal 8 equal 3. 0 at 0 equal 0, 0 at 1, 1, 0 at 2, 2, 0 at 3, 3, 0 plus 4 equal 4, 1 at plus 0 equal 1, 1 plus 2 equal 2, 1 plus 2 equal 3, 1 plus 3 equal 4, 1 plus 5 4 equal 5, 5 equal 0. 2 divided 2 at plus 0 equal 2, 2 add plus 1 equal 3, 2 plus 2 equal 4, 2 plus 3 equal 5, 5 equal 0, 2 plus 4 equal 6, 6 equal 1, 3 plus 0 equal 3, 3 plus 1 equal 4, 3 plus 2 equal 5, 5 equal 0, 3 plus 3 equal 6, 6 equal 1, 3 plus 4 equals 7, 7 equal 2. 4 plus 0 equal 4. 4 plus 1 equal 5. 5 equal 0. 4 plus 2 equal 6. 6 equal 1. 4 plus 3 equal 7. 7 equal 2. 4 plus 4 equal 8. 8 equal 3. Table for plus. Induce operation. Operation multiplied. 0 multiply 0 equals 0, 0 multiply 1 equal 0, 0 multiply 2 equal 2, 0 multiply 3 equal 3 equal 0, 0 multiply 4 equal 0, 1 multiply 0 equal 0, 1 multiply 1 equal 1, 1 multiply 2 equal 2, 1 multiply 3 equal 3, 1 multiply 4 equal 4, 2 multiply 0, 0, 2 multiply 1, 2, 2 multiply 2 equal 4, 2 multiply 3 equal 6, 6 equal 1, 2 multiply 4 equal 8, 8 equal 3, 3 multiply 0, 0, 3 multiply 1 equal 3, 3 multiply 2 equal 6, 6 equal 1, 3 multiply 3 equal 9, 9 equal 4, 3 multiply 4 equal 12, 12 equal 2, 4 multiply 0 equal 0, 4 multiply 1, 1, 4 multiply 2 equal 8 equal 3, 4 multiply 3 equal 12, 12 equal 2, 4 multiply 4 equal 6, 10 equal 1, 16 equal 1. Application number 5. Solve the equation in class residii modulo 7. 5a, 5b, 5c. Class residii modulo 7 equals 0, 1, 2, 3, 4, 5, 6. 7z equal is the class of residii modulo 7. Example 5a. Application number 5a. 5 multiply x equal 1. Law compound multiplication 0, 1, 2, 3, 4, 5, 6. 5 multiply 0, 0, 5 multiply 1, 5, 5 multiply 2 equal 3, 5 multiply 3 equal 1, 5 multiply 4 equal 6, 5 multiply 5 equal 4, 5 multiply 7 equal 2. X equal 3, z the table solution. 5 multiply 3 equal 15 equal 7 multiply 2 at 1. In class 7, 7 multiply 2 0 multiply 2 equal 0 at 1 equal 1. Check. 5 multiply 3 equal 1. X equal 3 is the solution. Application number 5b. 2x equal 3. 2 equal 3. 4x equal 5. 2, 5 equal 10. Equal 7 at 3. 7 equal 0 in class residii 7. 0 at 3 equal 3. X equal 5. Check is the only solution. Application number 5c. 6 multiply x equal 3. 4x equal 4. 4x equal 4. 6 multiply 4 equal 24 equal 21 at 3. 20 divided 7 equal rest 0 equal 0. 0 at 3 equal 3. 21 equal 7 multiply 3 equal 0 multiply 3 7 equal 0 equal 0. X equal 4. Check on the only solution. Application number 6. A equal R set minus 1 divided radical 3 minus 1 divided radical 3, and if index E define A, take value set A. E belong 1, 3 define as f1 x equal x, f2 x equal x at radical 3 divided 1 minus x radical 3, f3 x equal x minus radical 3 divided 1 at x radical 3. Any x belong set real number. Show that hash equal f1, f2, f3 is a party is established in relation on the operation of composition of function and composition by operation induced. Table number 1. Table number 1. Compound f2 compound f2 equal f2 f2 equal f2 at radical 3 divided 1 minus f2 radical 3. f2x equal x at radical 3 divided 1 minus x radical 3. F compound f2 equal f2 compound f2 equal 1 minus x at radical 3 divided 1 minus x radical 3 at radical 3 divided 1 minus radical 3 multiply x at radical 3 divided 1 minus x radical 3 equal x at radical 3 denominator common radical 3 minus 3x divided 1 minus x radical 3 multiply 1 minus x radical 3 divided 1 minus x radical 3 minus x radical 3 minus 3 f2 equal f3 f1 compound f1 equal f1 compound f1 equal f1 f1 compound f2 equal f1 f2 equal f2 f2 compound f3 equal f2 f3 equal f3 minus radical 3 divide 1 at f3 multiply radical 3 f3 equal x minus radical 3 divided 1 at x radical 3 f3 equal x at radical 3 replace f3 divided 1 at x radical 3 at minus radical 3 f2 plus denominator common x minus radical 3 at radical 3 at 3x divided 1 at x radical 3 multiply 1 at x radical 3 divided 1 at x radical 3 minus x radical 3 at 3 equal x equal f1 f3 compound f2 equal f3 f2 equal f2 minus radical 3 1 at radical 3 multiply f2 f2 equal x at radical 3 divided 1 minus x radical 3 f3 f2 equal f1 f3 compound f3 equal f3 equal f3 minus radical 3 divided 1 at radical 3 f3 equal x minus radical 3 divided 1 at x radical 3 f3 compound f3 equal x minus radical 3 divided 1 at x radical 3 minus radical 3 divided 1 at radical 3 multiply x minus radical 3 divided 1 at x radical 3 denominator common equal f2 equal x at radical 3 divided 1 minus x radical 3 from the table we can see that hash equal f1 f2 f3 is part stable in relation to operation of composition of function. Application number 7. R is defined by the law of composition. R product Cartesian R take value R x y correspond x compound y where x compound y equal from definition radical x at y at x multiply y. Show that the composition law is associative, commutative and has neutral element. Interval 0 infinite is stable part of R in relation to the law of composition. That law is associative denoted A. Any x, y, z belong R. X compound y compound z equal x compound y compound z. 1 compound 2 equal radical 1 at 2 at multiply 1 at 2. X compound y at x y compound z equal x compound y compound z equal y at z at y multiply z equal radical x at y at x y at z multiply x at y at x y equal radical x at radical y at z at y multiply z at x multiply radical y at z multiply y z. Relation 1. The square relationship 1. Radical x at y at x y at z multiply x at y at x multiply y equal x at radical y at z at y z at x multiply radical y at z at y multiply z. It follows that law is not associative. interval e equal 0 infinite is part stable in relation to law of composition P x y belong E. X compound x compound y equal radical x at y at y multiply z belong 0 infinite. Check. So interval 0 infinite is part stable in relation to law of composition that law composition is commutative, denoted C. Commutative. Any x y belong R. X compound y equal y compound x. X compound y equal radical x at y at x y belong R. False, because radical x at y at x y belong R plus. So law is not commutative law. And law permit neutral element. Any x belong R exists x index n belong R where xn is the neutral element, so that x compound xn equal xn compound x equal x compound xn equal x at xn at xn. Radical x at xn at xn equal x. Relation 2. It raises the relationship 1 square. X at xn a factor common n at x equal x power 2. Xn equal x power 2 minus 6 divided 1 at x equal x multiply x minus 1 divided x at 1. X at 1 different 0, x different minus 1. So the law do not allow neutral element, admit a neutral element only R minus 1.